All right, it says in the above equation, C here is a constant. If the equation has exactly one real solution, what is the value of C? If I take a look at the original equation here, which I am going to write down again once more, it doesn't look quadratic. However, if we are to expand this, if I distribute the 4x on the inside, I get something where I now notice an x squared. And whenever we see an x squared looking thing, a quadratic looking thing, I say to myself, this question might be testing me on something about the discriminant. Now, when we talk about the discriminant is the part under the square root in the quadratic formula. That's that b squared minus 4ac thing. As a reminder, the a, b, and c here are when we talk about standard form of a quadratic when it's set equal to 0. There are three cases of the discriminant. When we're talking about it having exactly one real solution, that means the discriminant is equal to 0. So I want b squared minus 4ac to be equal to 0. But in order to figure out what a, b, and c are equal to, I have to massage my current equation and make it look more like this thing on the right in red. So I'm going to subtract the c on both sides, and that would get me 4x squared minus 4x minus c equals 0. Now this is in standard form, and it's also equal to 0. It looks like a is equal to 4, b is equal to minus 4, and c, it looks like it's equal to minus c. This looks very, very weird, but this is something we have to be very careful about when we do plug in to the discriminant. We're not saying that literally the constant c is equal to minus c, because that would mean that c is equal to 0, actually. I just sort of use these a, b, and c's in the original discriminant as sort of a placeholder when I plug in. So I know the discriminant, which is b squared minus 4ac, is equal to 0. Plugging in, I get negative 4 squared minus 4 times 4 times minus c equals 0. Simplifying this, we get 16 plus 16c equals 0. Dividing everything by 16 give us that 1 plus c equals 0, which implies that c is equal to minus 1, giving us our answer.